Okay, next question. Diagram below shows a block of concrete with a hole in it. Gemma wants to measure the volume of the hole in the concrete block. Which of the following best shows the apparatus she should use in order to do so? Alright, so what can we use to measure irregular shapes like that? Okay. Okay, now let's think. Okay. What has a fixed volume but an irregular shape? What can we fill this hole with? Alright, and then find out the amount of whatever we use to fill this hole in. Wait, let me check. Close. Okay, so let's say we want to measure the shape of an irregular object. Let's say this is a stone that I find in our science garden, and I want to measure the volume of this irregular stone. Now this irregular shaped stone is very hard. I cannot get the measurement. I cannot use a measuring tape or a ruler to measure the dimensions, and then like in maths you can have length times breadth times volume. Well, that works for regular shape objects like a cube or any kind of cuboid. Okay, but for irregular shapes in science, we often meet things that are not not so mathematical. Okay, so what do we do? Okay, normally what we would do is we take a measuring cylinder, fill it up with water, and then put this object inside here. Okay, so if let's say the volume, when you put a solid, remember a solid has what? A solid has a regular shape, alright, or a fixed, fixed shape and a fixed volume. Am I right? Okay, so because a solid has a fixed shape and a fixed volume, okay, when we put the rock, okay, or the stone or the pebble into a container of water, it will fill up a certain amount of volume, alright, and whatever the new volume is, alright, whatever the new volume of the water is, okay, I'm sure that if you put the rock inside a cylinder with water, the water will rise, right? Same thing as you submerge yourself in a bathtub, the water will rise. If you put anything in the basin of water, let's say you want to wash your cup, put in water, I'm sure you can observe that the level of water will rise because the solid that you put into the liquid, okay, will have its own fixed volume, and this fixed volume will add to the total volume of water already in the cylinder, and the water will rise because of the added volume. So the difference that you can find here in between these two lines, that is actually the volume of the solid. Alright, why? Because solids have fixed volume. Okay, if you understand that, okay, go to my website here and say, yes, Mr. Zaki, I understand why the water rises in the measuring cylinder when I place the solid into the container of liquid. Okay, because liquids, alright, also has a fixed volume. Okay, so solids have fixed volume, right? Solids have fixed volume, and actually so does a liquid. Okay, we do know that liquids have what? Liquids have irregular shape or a not fixed shape, right? Liquids have a shape that is not fixed or indefinite shape. Okay, so a shape that is not fixed, alright, not fixed, the shape is not fixed, okay, not fixed in terms of shape, but it still has a fixed volume, right? Okay, but it has a fixed volume. So a fixed volume add to a fixed volume, then you will have what we call a total volume. Okay, so because liquids have fixed volume and solids have fixed volume, the two volumes added together will give you this rise in water. So you know that the original level of water minus the new level of water, that is what gives the volume of the irregular shaped stone. Okay, now if you can understand that, so we can answer this question. Now, this question is very similar to this. This time we won't have all this. Okay, I'm gonna remove all that. Alright, now this time what we can do is we can use a measuring cylinder. Okay, we fill it up with a known amount of water. Alright, known amount of water. Let's say we know that this is the amount of water. Say one. Let's say this is 10, 20, 30, 40, 50, 60, 70 ml. Okay, I'm just giving you any random number here. Now, if this is 70 ml and I pour some water, oops, and I pour some water, okay, let's say this is 70 ml, okay, of water, and I pour, something is wrong here. Let's say this is 70 ml of water, okay, and then after I pour some of the water here into this hole. Okay, now imagine that this hole is now filled with water. Okay, this hole is now filled with water. Okay, will the level here increase or decrease? Remember, liquid has a fixed volume of water, but I've poured some into the hole. Okay, what would happen is that the water will decrease now. Am I right? The level of water will now decrease. So let's say after the volume of water, what happened is it decreases. Okay, so instead of here, the top level, now it has decreased because we've poured some of this water here. Okay, until it totally filled up the volume. Okay, so what is the volume of this water here? If this is 70 and this is 60, then the volume of the whole would be 70 minus 60, which is 10. Okay, do you understand this? Now, if you do understand this, again, go to this website and say, yes, Mr. Zaki, I understand. If you don't understand, go to this website and say, Mr. Zaki, I still don't understand. Can you explain it to me when I meet you on tomorrow? Okay, then I will explain to you again. Maybe I will show you with the beakers, because right now at home I don't have a measuring cylinder. Okay, so it's very hard for me to show it to you right now, but in school I would be able to show it to you. Alright, so now Gemma wants to measure. So with that explanation, what do you think Gemma can use? Can she use balloon and measuring tape? I don't know how you can use the balloon with the measuring tape, because if you were to blow the balloon here, you're gonna have a hard time, because the air trap in the concrete would not allow the balloon to be fully inflated. Okay, and furthermore, air can be compressed. So regardless of how much air you pump in, it will not tell you exactly the volume of the hole. Marbles and measuring scale, now you're trying to find volume, you're not trying to find weight. So the measuring scale won't help, and if you fill the hole with marbles, you can't fill it completely. Why? Because in between the marbles there will be air spaces, and you really can't find out the volume of those air spaces. It will take a lot of mathematics, very difficult. Alright, you can use water and measuring cylinder. This is what I'm explaining right now. Can you use measuring tape and calculator? Well, if it's an irregular shape, your measuring tape would help. Okay, you really can't tell how which is the length, which one is the volume, and which one is the height. Okay, so with that, the answer here is 3, and I hope you've understood my explanation. If you have not, again, what must you do? Ask me. Okay, and then on when school reopens, whenever that may be, I will come to me and then say, Mr. Zaki, I don't understand that measuring cylinder thing, and I will explain it to you again. Okay, with that, thank you very much. Till the next question. Okay.